recording. So I've gone over all of your landscape and water things, and apparently it caused Munkers to drop. This is a games class. It's not supposed to be. It's not supposed to be a death class. The YouTube lecture that I posted has all the steps on it, and you can always just ask me if something's not working. So today we're gonna take a step back away from Unreal Engine. I'll give you guys another 2 days, I guess, to get the landscape and water assignment done, because it actually is a really good tool to have in your arsenal for making nice looking environments. You just have a couple different textures, and you can do some macro texture variation on it so they don't tile noticeably, and a little bit of hand spray painting, a little bit of automatic foliage generation. You can actually make a world that looks like decent in a fairly, short order. It's a lot better than just spray painting all those lumps by hand, like forget about it. One thing I did show my IS50B class that I didn't show you guys because I didn't want to confuse you, but I don't know, maybe you'll like it. I'll actually fire it up real fast so you can see maybe kind of a better way of doing this a little bit, which is you can actually import materials from like the Unreal Engine materials rather than kind of making it yourself with like a texture, which is a texture is just a 2D picture, and a normal map and all that kind of stuff. You can actually just import a full-on material into your landscape, and you can do that by creating what's called a material function. And so you can turn any material into a material function. It's a little bit annoying to do it, but you can do it. And so here is my world. You can see it. It's all right. I mean, I'd want to spend more time on this, but it's all right. It looks decent enough for the purposes at hand. And so let's see, open level IS50B smart map. Okay, so here is the smart map I made for IS50B. So you can see there's areas where I've spray painted flowers. You have 5 different types of flowers here. It's very beautiful. And then there is a volcano up here, and I spray painted rock on it. I missed a spot right there to get rid of the plants on it. So this one is just two different textures. Flat area is grass, angled area is slate, and you can see there's a normal map on it that kind of gives it some shadows and definitions, and it looks all right. And so you get closer, you can see do you see how the flowers are filling in here? There is a far clipping plane on the foliage, so after I think it's like 100 meters, it stops drawing. That's a setting you can set. It's not necessarily part of the engine itself. You can choose how far away the foliage draws, like that. You can see the flowers are kind of filling in up there as I get closer to it. So so with this material here, let's see, IS50B Smartland. There it is. Double click. Thank you. Okay, so what I did was I made what's called a material function. So I took the Unreal grass material and I turned it into a function, and then you can just import it like this, so you don't have to kind of recreate the whole thing in here. You can just import a function for grass, import a function for slate, and then when you pull out from it, there's a node called break material attributes, and that can give you the normal map, the roughness, the color, all that kind of stuff from it, rather than having to do all that by hand, which is kind of nice. So yeah, all that isn't really being used right now, is it? I would need to hook those up, but whatever, not using it right now. So I'm just going to delete it. I've got the world aligned blend in here. I've got 2 parameters for sharpness and bias, like we talked about last time. And so basically what I did was I pulled out from these material functions, I'll show you in a second, I pulled out the color and I pulled out the normal maps, and then I ran those through the WAB nodes, so it lerps between the 2 different textures. using roll line blend, and alerts between the two different normal maps and the two different roughnesses using the same roll the line blend. And so that way you don't have to copy and paste a lot of code. You just do that. And then I fed the output of the texture blend into a layer blend, and the layer blend allows you to choose between the auto texture, and then I just chose grass and rock again on top of that. And what's nice about that is that you can actually kind of erase the so if you have a layer that's the same as, like, I've got slate, I've got grass, and then I created two more layers that are slate and grass. And what that allows me to do is it allows me to like have more direct control over over the layers here, right? So this flat area in here, by default, is grass, right? Because it's flat. But it looked weird having grass on the inside of a volcano, right? So if I spray paint the default texture on top of it again, you see how the grass comes back, and that looked kind of weird, you know, having grass like in a volcano. And so what I did was I just chose the rock layer and I spray painted over it and just cleaned up the areas that I thought should not be grass, like that, around the lip. And then everything lines up nicely. And let's not have any flowers growing here. Just erase it. And so you can use that to kind of clean up your textures. Any place where the auto texture doesn't really look good, you just do that and clean it up. So how do we make a texture function? So let's go into the starter content and go into materials, and we'll just search for grass. And so what you can do is go into the grass node that Epic makes, and it's quite nice. It's got the macro texture variations, so if you zoom in and zoom out on it, you don't see tiling on it. So rather than recreate that whole thing, you just select the whole thing like this. And what do we got here? We got roughness of 1 and normal map and a base color. Okay, so I select everything except for the end node. Hit Control C. Being able to control texture tiling. See how like you don't see repetitive tiles on this grass here? Like there's darker areas and lighter areas, but like there's no noticeable pattern to it. It's because they have a high frequency, medium frequency, and low frequency noise that gets mixed in, and it blends different textures together based on the lerping, the white and black values of the noise. And so it creates actually quite a nice thing. And if you get far enough away, it'll actually fade to a single color. If you zoom out far enough. Maybe I can't go far enough, but it'll turn into just a solid color at a certain point, right? And so then as you get closer, you can see the details start coming in. I need to rebuild the lighting to get rid of those grid lines, but yeah, so you can go all the way in on it, all the way in. You can see that each of these squares has a different pattern on it, so quite nice. So all I did is I went in there, I copied everything except for the final node, and then in the build section, I created, no, I already got it there, so I'll just make a new one. Right-click materials, and it's called material function. So if you want to import one of their materials in, you turn it into a function, and functions could be imported into other materials as just a single block instead of copy and pasting all of that garbage. It's not garbage, it's great, it's beautiful, but it's messy. And so rather than having to copy and paste all of those nodes and have wires running everywhere, I just make a material function. I'll call this delete me because I already got it in there, right? Delete me, there you go. And so what I'm going to do, this output result here is going to take the same spot basically as this here. So when you're in a material function, zoom out, come over here, hit paste, and so all of those nodes are coming over here, and the thing you have to set is called make material instance. Make material attribute, sorry. And then this, basically you feed in all of the results of the material get fed into the relevant parameters here, And then on the opposite end, so that's the base color here. This is the roughness here. And then down here we've got the normal node, right click. Let's see, connect to result. Let's see if that works. No, not result. We want to the normal map. Sometimes it'll have a little option here to connect to specific things. So I'm going to drag that over here and plug that into the normal map. So step one, go into a material you want to copy. Copy everything except for the end node. Copy everything else. Step two, make a material function. Step three, paste. Step four, connect the step four, create a box called make material attributes, a node called make material attributes. Step five, hook up the things to where they were before over here. Right? Base color, roughness, normal. Base color, roughness, normal. Step six, hook it up here. I showed this die as 50B because I was worried it'd be too advanced for you guys. But who knows? You guys are all smart. So once you have that, then you can come into your landscape thing. And you can come to your landscape and you can just snap it to the side like this and come into the content browser, have delete me, and you just drag that in. And that is the entire material in just one node. And then what you do is you pull out from here, break, it's hidden by my face. You pull out from that entire material function, break it open, basically. And then that will give you all the stuff. And if you want, you can just connect it up, and then it'll be grass, right? So if I were to connect all these things up, it would just turn the entire landscape into grass. But what I did at that point was I lerped between the two different colors, lerped between the two different normals, the two different roughnesses. I actually overrode the roughness. I didn't use the roughness of 1. I made it a roughness of 0.85 so I could control that. And that's a slightly more efficient way of doing it, I guess. So you don't have to like recreate all these textures from scratch. You can just steal existing ones. All right. So that is water and landscape. So I'll give you guys till Thursday to finish that. I'm not going to talk anymore about Unreal Engine today because we're going to talk about something new. When are you going to fix my grade? It's still showing the bad score for the math grade. Well, I can do that right now. I thought I deleted it already, honestly. It's still there. Okay, it's gone now. Sure. Okay. There you go. It's gone. All right. So we're going to talk about math now. Speaking of math quizzes. So the Canvas will turn on things even if I turn them off sometimes. It's not great. So let's talk about math. It's what everyone's been waiting for right now, the math. So before we get into the math, it's really important to understand the basics of game design. So let me hide my face. You don't need to see my face. Let's hide my face. Like that. And we're just going to have a little lecture right now. So when I started working in the industry, I was handed a math book, right? And so what I'm going to teach to you guys today is really the basics of what's actually going on when you have a 3D video game. We're talking about 3D video games, right? So everything is based on triangles, basically. So if you have a square in a game, it's usually 2 triangles, right? You can build a square out of 2 triangles. If you have a tree or something like that, it might be thousands of triangles, and you'll see them in, like, if you ever see tree, wire, frame, mesh, if you've ever seen this, you know, you can see this is quads actually, not triangles. Same principle. Each quad is 2 triangles. So you can see that when people model things in 3D, these are all quads. Just give me a triangle mesh, dude. There we go. So here's the landscape, right? So if you have triangles, you can approximate curves and shapes like that on the world. And so, for example, the landscape that we've been making is just a bunch of triangles. And so you see every 2 triangles is just a quad. And so by having enough triangles, you can make very smooth looking surfaces. If you use less triangles, it will look less good. And so the more triangles you use, the better your game will look. If you look at old games, the triangle budget was fairly small. And so you could oftentimes count the triangles on the screen. You know, here's a race car or something. You can see if you look at all the different triangles on here, it can be quite detailed, right? Curves require more and more triangles to use. So areas that have to have curves on them require a lot of triangles, like that. The side view mirror here requires a lot of triangles. Flatter areas require less. Okay. And so if you look at like the Quake, you know, Quake soldier, you know, you can literally count. You know, it's like, all right, he's got 2 triangles for the arm. You know, and his face is like 6. You know, so yeah, the original Tomb Raider. That's another great example. You can literally see the triangles on it. And then as games have gone more advanced, you know, obviously there's more and more triangles involved in there. Yeah, here's yeah. Yeah, you just sit there and you can really just see the triangles. And so there's a lot of tricks that we use to hide the fact that we don't have a lot of triangles. We'll get into that more later. So here's a triangle. And so every triangle has an X, a Y, and a Z coordinate. The guns from the newest Call of Duty are 70,000 triangles. Yeah, it's reasonable, I guess. Maybe it's not reasonable. I don't know. It's a lot of detail. So here's a triangle, right? It's 3 points. And one question is, do you draw the triangle clockwise or do you draw a triangle counterclockwise? Which one do you guys think? Which way do you think triangles are drawn? Clockwise or counterclockwise? Just had to take a guess. I mean, this one is counterclockwise, I guess, but Hayburn said clockwise, and the actual answer is it depends. Usually you can set that as a setting. And why does it matter which order you draw a triangle in? And so GPUs, I believe, can be set to do it either way equally well. And so the reason why it matters is because you need to know what side of the triangle is the front and what side of the triangle is the back. And so if I were to take this triangle here and just flip it around, like if I put this on an index card and flipped it around, you would see that it would go V1, V2, V3. It would go from being counterclockwise. If I flipped it around, V1 and V2 would be flipped, right? Then it would go V1, V2, V3, and it would be clockwise. And so this is really, really important. This is something called back-face culling, where game engines by default will not draw triangles that are backwards. And the reason for that is if you think about any object, you can only see triangles facing you. Triangles on the backside are not visible. It is not visible. Like, look at any 3D object in your house. You can see only the triangles that are facing you. You can't see triangles facing away from you for solid objects. For planes and things like that, it can actually matter. Leaves and things like that, it can matter. But for any 3D shape, you cannot see the triangles on the back side of it. They're occluded. You cannot see them. And so it's really important to always draw your triangles in one way or the other. And if you import something and the triangles are backwards, then you have to, if you're lucky, you just set a checkbox. But if you're not lucky, then you have to like redo the mesh or reprocess it. Eyeball bug, Red Dead Redemption. So if you've ever seen games where like the camera moves inside of the head of a character and it stops drawing everything except for the eyes. No. You guys know what I'm talking about? Like, the camera moves inside of a solid object, and then suddenly, let's see, Pan Am, Airbud. Yeah, when you're trying to find it, you can't find it. You guys know what I'm talking about, right? The camera moves inside of a solid object, and all of a sudden it goes transparent from the inside. There's a bug in Cyberpunk where if you die on one of Pan Am's missions, it spawns you not in your car seat, but in her car seat, so you're looking out through her head. And so it draws the hair, and it draws the eyeballs, which is really disconcerting, but it doesn't draw the face, because you're looking out through the face. And so all those triangles are on the back side, so it doesn't draw them. So the downside to using backface culling is that if your camera gets within a solid object, which should not happen, but it does happen, then it turns transparent from the inside, right? So if you have a cylinder, like a 2D surface like this, then all the triangles facing the opposite way don't draw, right? And so usually you want backface culling to be on because it's a very, very fast way of accelerating your game. You don't, there's usually no reason to draw the backside of a triangle. It'll double your frame rate, essentially. Yeah, so... yeah, if you're outside of a world, for example, it might not draw, properly, things like that. So you'll see bugs from it, but it's always worth turning on, in my opinion. Yeah, there you go. Thank you, Lave. So let me snap that over. Those of you at home, yeah. So if your camera is inside of a face, then the face vanishes. But oftentimes the eyeballs and the mouth are drawn separately because they have separate engines for rendering facial expressions and things like that. And the hair system oftentimes will be drawn too, and so you get these really creepy, bugs sometimes. Okay, so yeah, so you can combine triangles into shapes. Basically, any as the number of triangles you have goes to infinity, you can more and more accurately represent any shape in the world. A sphere, for example, takes an infinite number of triangles, essentially. But really, you don't need any more than like one per pixel, really. So that's still a lot of triangles. And so typically a sphere will be represented like some sort of angular ball. But flat surfaces can be done very easily, right? A square can be done with just two triangles. There's all sorts of ways of combining triangles together to form meshes. You'll see quads or a quad strip like we saw with those trees earlier, where they attach a bunch of quads together. A triangle strip is very common as well, where you have a bunch of triangles attached together. You notice that all of these are counterclockwise, right? 1, 2, like that's the order that they're drawn in, so that you know which way is forward. And so when you use a modeling tool like Maya or Blender or something like that, it'll export a mesh, which is generally speaking just a bunch of points in space and then connections between those points. If you've taken Seaside 26 with me, it is a graph. And so one of the nice things about doing a triangle strip like this is that you don't have to repeat the vertices every time. Like if you have a bunch of triangles like that, it's 3 triangles per vertice, right? But here, like check this out. Vertex 0, vertex 1, vertex 2. If I want to add another triangle, I only need to add one more vertex. You guys see that? So 1, 2, 3 for the first triangle, but then the next triangle is just the 4th vertex. So, and then the next one is just one more vertex, and then the next one is just one more vertex, and the next one is just one more vertex. So basically, you can get to a point where you can actually represent a triangle asymptotically down to like a point. So rather than needing 3 points per triangle, you need 1 point per triangle, and that's nice. That's a huge savings in space. You can load your meshes a lot more efficiently that way. Another way you can do it is with a triangle fan. So your first triangle, again, is 3 points, because you can't get away from that. 1, 2, 3. That's 3 points on a triangle. And then the next one is 1 point, and that defines the next triangle. 1 point defines the next triangle. 1 point defines the next triangle. And so you can do it that way as well. With a quad strip, it's 2 points, and you get a quad. 2 points, you get a quad over and over again. So those are the different ways meshes are held in video game engines. So what do we know about a triangle? First of all, any questions about this? You don't really need to know this. In Unreal Engine, you just sort of drag a mesh in, and it just sort of magically appears in the world. However, there will be times where you drag it in, and you see the backside, but you don't see the front side, and then you go, aha, aha, backface culling is getting me. Any questions about it? Does this make sense to you guys? So triangle is just 3 points, but there are ways you can just use 1 point to stick a new triangle on. And this is mostly done by the art people. I'm not an artist. I don't really have very good modeling skills. I've done it before. I'm not very good at it. But like when you work in Blender and Maya and things like that, you'll create these things and then you kind of drag and drop them into Unreal Engine to import the assets. Okay, so what do we know about a triangle? So a triangle can be defined either as 3 points, or it can be defined as 2 different vectors. So a vector is 2 points, right? And so in this case, the triangle is represented by A to B and A to C, right? So it's the same thing. It's still 3 points, A, B, and C, but you can think of it as just 2 different edges. The third edge can be deduced by subtracting one of them from the other, and subtracting B from C will give you a vector. It'll give you that edge essentially. I've always wondered what the cost of backface culling off versus doubling the plane and flipping it is. If you have a plane and if you have a 2D surface, you generally need to turn off backface culling. If the user can go on the backside of it, like the water plane. If you want to look up and see the water surface, you need to have it be double-sided. So we got the 3 points, right? But then we've also got this thing called a normal vector. And so you guys have been playing with the normal maps this whole time. And so what the normal vector is, it's the direction perpendicular to the surface of the triangle. So this is used for lighting. Light bounces off around the normal vector. So light will come in and it'll reflect off, using the normal vector as sort of the thing that it reflects around. And so when you guys were playing with the normal maps, what you were doing was saying, at this point, the normal map is going this way. At this point, the normal map is going that way. At this point, the normal map is going that way. And what that does is it causes the light to bounce off this triangle non-uniformly. If you don't do it, it'll just bounce off as if the triangle was a flat triangle. But with a normal map on it, every point on this triangle can have a different angle to it, so to speak. And so that simulates, cobblestones and slate, the little shards of rock coming off of it and things like that. It's a really nice way of getting more detail into your world without actually using more triangles. You can have a triangle with a normal map on it, and then it will sort of simulate, to a certain degree, it's not perfect, a higher quality surface with more triangles in it. So counterclockwise A, B, C means we're facing it. If we draw the triangle clockwise, that means that it is away from us. And so we usually don't draw the backside. We usually don't. You can enable it if you want. There's also an area to the triangle. We know how big the area is. And the normal vector, though, is really important. And so if you're going to shoot a ball at it, the ball is going to bounce off around the normal vector. So whatever angle the ball comes in, use my tablet. So let's say you're making a racquetball game, and the racquetball collides with this particular point on your wall. Okay, and so you've got a ball, and the ball comes in here. There's an angle here between the normal vector and the ball, and the ball will come right back off in the same angle in the opposite direction. So it's going to reflect this way, So whatever vector going down is now up, and the angle coming off is, well, yeah. Basically, the angle coming off is the angle coming in just on the other side of the normal vector. So that's how you do things like bouncing, and if you have a laser that shoots off, that reflects off a wall, it reflects around the normal vector. And we'll learn how to do that later, mathematically. But the normal vector is very important. So you've also got a color on it. So every triangle has a color, usually. And you guys remember how you guys use base color? In this case, we would have a sphere with a base color of red. And you can do more complicated things than that, but at the most basic level, you can just make it red if you'd like. And colors range from 0 to 255. 0 is nothing, 255 is maximum. So if you have a color that is 255 red, 255 green, 255 blue, 255 alpha, alpha is used for transparency, then you will get a white surface. So if you have 255, 0, 255, you will get a purple surface. Full red, no green, full blue, that is purple. If you get 255, 255, 0, full red, full green, no blue, you get yellow. And so by default, it'll just apply the color to the entire mesh. But you can do things like what we did, where you have textures and things like that that make it a little more interesting than this. And so in addition to color, you can also have lighting on it. So the lighting of a object can be set in different ways. This is called flat lighting, where the entire triangle has the same color. And then there's better color schemes where it will actually blend the normals between the different edges of the triangle, and you can get. I mean, this looks like it's a round, smooth surface, right? Even though it's the same number of triangles, by using a better lighting model. So Grand shading was used back in the 90s. You can still see that there's a vertex right there, So you can kind of see the outline of like the seams of the triangles there. So garage shading was used a lot in the 90s. Nowadays, it's kind of not very good. It's faster. Like flat is obviously faster than garage, which is faster than Phong shading. But CPUs or GPUs are so fast these days. There's no reason not to use the best quality. And if you want to get into lighting, like lighting is like, oof, that is a complicated topic, because light bounces off objects, right? And so you've got direct illumination, but you've also got global illumination, where light bounces around a room. And that's, you can take a class on that, honestly, just on lighting, 3D games. RTX, yeah, exactly. And how that works is actually really interesting too. But we're not talking about that today. I do have a lecture on lighting. So then if you want to step up from just a solid color, we did this in Unreal Engine, right? We started with a solid color and then we applied a texture to it. So texture is just a picture. And so you can choose to apply a picture to a triangle. And so if you have like a picture of daisies on disk, it's just a little picture. It's like a Windows XP background or something like that. If you got a picture of a triangle, or you got a picture of daisies, and you want to put it on a triangle, the question is which part of the picture goes on the triangle, right? Do you guys understand? Like where should it be rotated to the left? Should it where? How exactly do you map this picture to the triangle? Do you guys understand what the problem is? Like which part of the when you're texturing something, like which part of the picture goes on which part of the triangle because you can scale the picture up and down, right? We were doing texture tiling, so you can make this picture bigger, make the picture smaller. You can slide it around on the triangle. How do you map between a picture and actually applying it to a triangle? Different portions of the image would show, yeah. And if you've got multiple triangles, then they've got to be picking up multiple parts of the picture. What's up, girl? Okay. And so this is called UV mapping. And so on a triangle, we have X, Y, and Z, right? We have the horizontal, vertical, and depth, right? Z is usually depth, how far away something is. So we've got X, Y, and Z for the triangle, and then for the picture itself, we have U and V. And U and V stand for the texture coordinates. And by messing with U and V, in Unreal Engine, you'll see it as a UV input, right? It doesn't stand for ultraviolet light. It stands for texture coordinates, right? So what do you have here, Zach? Oh, yeah. So let me pull that up. Open original. Yeah, so people that get into texturing and modeling, you'll actually have a single image like this, and then what you do is you map chunks of this image here to different parts of the mesh. So if you go into like Blender or something like that, you could be like, all right, the guy's arm, and you like click, and you choose to map this picture here onto the triangles for the arm, and maybe that becomes, I don't know, the eyeball. No, the eyeballs are these things, and so this gets mapped onto the face, and this gets mapped onto, I don't know, the back or something. I don't know what this is exactly. But yeah, so basically you just have a 2D picture, and then you select a spot on the picture and say that spot is going to correspond to this spot on the triangle. And so if we look at our materials, that's an instance. If we look at our materials, you can see there's a UV input, right? And so the UV input does not stand for ultraviolet light. It stands for the coordinate. Like how do you map this triangle onto the mesh? And
it doesn't stand for ultraviolet light. It stands for ultraviolet.
No. And so you can do things like put a panner in here. You can put a panner node in here, and speed. You can play Scarum, yes. And so you can have your texture animate. See? It's probably a little too fast. Hey, do you see that?
Yeah.
Yeah, it's kind of cool, right? It's
weird.
Weird. I mean, sure, I guess. And so you can see that this material is now animated, and what it's doing is just changing the. Maybe I shouldn't quit. No, whatever. What it's doing is just changing where the picture maps to. It's not actually animating anything. It's not. Is Panner moving the coordinates of the triangles? It's not moving the triangles at all. It's changing the UV coordinates, and so it's changing where the picture maps to the triangle. And so it's just sliding. You can think of it as just sliding this. You can think of it as just kind of like sliding the picture around. The mesh stays the same. The triangle stays the same, but it's just sliding the picture around on it. So it looks like you're doing this cool animation, and really you're not. It's just changing the UV mapping of the picture onto the triangle. And so for a complicated mesh like this, you have to come in and say, okay, click, the nose cone is this point, and then these 2 points here are these points here. What it's going to do, it's going to take this triangle, this triangular section of the picture, and it's going to draw it on this triangle here, and then this triangle here gets this one, and this one down here gets this one. And what you'll do at the end of the day is have this picture mapped to the cone very nicely. And you can do things like use the text chord node to make the picture bigger, make the picture smaller. So that's what's going on behind the scenes, and that's why it's important to study the basics, which I'm talking about now, because now that you've been kind of doing it a little bit, it'll kind of make more sense to you, I think, as to what's actually going on. Like I said, there's a lot of terminology. There's a lot of terminology in game design. And so in Unreal Engine, it's just like UVs. And you're like, what the hell is a UV? I don't know. And And so now, like, why is there a node called text chord? Well, that's what you're feeding into it, is you're feeding in a scaling for the texture coordinates. And so you can make the picture bigger or smaller, which will cause the pictures to be bigger or smaller on the mesh. And so, like if you had a big image like what Zach posted a second ago, you can actually select chunks of the image and apply it to different chunks of the mesh. And you do this UV mapping usually in Blender and things like that, where you actually go click, 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 and click, 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 and you select chunks of the image, and you select which vertices to apply it to. Okay. This all just clicked, yeah. Some of you guys were doing this probably in a Tabletop Simulator as well, right? Where you have like a giant image. I remember Rivera talking about that. You have a giant image or something, and you have to apply chunks of it to the different cards. Okay. So, any questions about this? You unwrap 3D objects to be flat, kind of like reverse origami. Yeah. That's one way of thinking of it, right? So you say this face is here, and this face is here, and this face is here. And so if you ever heard about reskinning something, all they do is they get the PNG file. Let's see if I can find an example of that. Skins. So here is a Quake soldier skin. And so what happens is that it maps these points to the arm. This is the backside. This is the graphic for firing. It creates like a 1, 2, 3, 4, 4 triangle thing, an explosion coming out of it. And so you can just open this in Photoshop and just like change the color of the guy's axe, and unless you move it, which would require you to remap the UV coordinates, which you generally don't want to do. You can actually just sit there and like come in and change his pants. I'm like, I don't like his pants. You just edit in Photoshop, just kind of open with I don't know if Paint can handle it. MS Paint. Unknown file type. Great, fantastic. Well done, Microsoft Paint. And yeah, you can just come in there and spray paint different colored pants and stuff like that. So that's a common modding that people do, is they just find the skin file and then they change it. Okay, so what can you do with triangles? Well, triangles, there's 3 things you can do with triangles. The 3 main things you can do with triangles. And these should be fairly familiar with you from having played with Unreal Engine for 6 or 7 weeks at this point. And the first is translating, which means you move it around. Second is rotating it, or you spin it. And the third one is scaling it. You make it bigger or smaller. We don't often actually scale very often. And the reason for that is because when you scale something up, you know how the textures like it all washed out and stuff like that. So scaling, yeah. In general, you kind of want your meshes to be at the right size for the world. So your texture artists will make it at the right scale, so you don't have to scale things up, scale things down, which breaks, tiling and things like that. So in general, you want your meshes to be sort of at the right size already, but if you need to, you can make something bigger or smaller. You just have to be careful it doesn't look like crap afterwards. Transform schema, yeah, that's important. We'll talk about that later, though. So here's math. And so your first math quiz will be on this topic here. It'll be on transforms. And so here we have a triangle. It's got 3 points. For these quizzes, they'll, in general, be in 2D. I might do some in 3D. I don't know. But 2D is, the principles are the same. It's just less typing, And so if you want to move a triangle to the right, like here we have a triangle ABC, and we want to move it to ABC, it's going to move 1, 2, 3, 4 to the right, and 1, 2, 3 up. Okay, and so what happens is that the coordinate of A and B and C all get translated, all get added in the same amount, right? So A before was at -3, 0. And A afterwards is at 1, 3. Do you guys see that? So if you want to move it 4 in the x direction and 3 in the y direction, the x part gets +4 added to it, and the y part gets +3 added to it. And then you do the same thing for B. B before was -3, -2. And B after you translate it here is at 1, 1. C before was at -1, -2. C afterwards is 3, 1. Can you guys do arithmetic? Is this easy enough? Can you add 2 numbers and 2 numbers? 2 + 2 = 4? No, that doesn't sound right. Add 2 numbers and 2 numbers together. Right? So if you want to move, yeah. Maybe. Right? And so what the net effect is, if you move all of the points to the right by 4, and you move all the points up by 3, then what happens is the triangle goes from here to here. So move 4 right and 3 up. And as long as you do the same transform, +4 + 3, if you do the same transform to all 3 of the points, then the triangle just moves. And so when you're sitting there and just clicking and dragging something around in Unreal Editor, that's all it's doing. It's just adding numbers. That's it. So if you wanted to move something to the right, so let me erase the annotations there. Okay. So let's see if you guys can figure this out. If I wanted to do a translation where I'm just moving to the right by 7 units. No change in the y direction, just to the right. What would the A before was at -3, 0. So you guys ready for this? What is A going to be after we transform it? We're moving it 7 units to the right. Before it was at -3, 0. And we're going to move it 7 units to the right. So it's -3, 0, and we're moving it to the right 7 units. So 3, -3 + 7 is 4. So A would move from here to here. Okay. What about B? B is at -3, -2. What is B going to be after we move it? Question mark. So we're translating B 7 units to the right. Okay. So this one is also for in the x, because it's at -3, so it's moving to the right 7. The y value is not changing, so the answer is going to be 4, 2. It's going to be here. If it was -4, -2, that would be here. So it's moving to the right 7 spots, and that's why I like kind of graphing it out. You know, it's because you can actually see if your math is correct. And then C is at -1, -2. So what is C prime afterwards? We're translating it to the right 7 units. So before it was at -1, -2. After we translate it to the right by 7 units, it will be at what? Good. Yeah, it'll be at 6. My mouse. It'll be at 6, 2. Because -1 + 7 is 6. The y direction doesn't change. And so if I draw a little triangle here, you'll see the triangle move from here over to here. Okay. So if you, yep, very good, you guys got it. So yeah, hey Ada, can you come here, girl? I want to see if Ada can do this. All right, so we'll do one more. Let's translate C, which is -1, -1, -2.
Yeah.
And we're going to translate it 5 up.
What is it?
We're going to move it 5 up. 1, 2, 3, 4, 5. We're going to move it 5 up, and we're going to translate it 4 to the right.
Why did you call me here?
I want to see if you can do math.
Of course I can do math.
Okay, so you have to add up 2 different groups of numbers. You have to add -1 and 5. I know that's pretty advanced, and -2 and 4. So what's the answer?
-2 and
4 added together is
2.
2. Very good. So the y is going to be 2.
4.
And then this one's going to be 4. Yeah. So if we translate it 5 up and 4 right.
For 2.
1, 2, 3, 4, 5. Oh no, sorry, 5 right.
Oh, I have to do more.
No. I wrote it wrong, girl. It's not your fault. 1, 2, 3, 4 up. 4 up and 5 right. 1, 2, 3, 4, 5. Then sure enough, we get 4, 2. So. Yeah. So that is that's transformations. So, or that's translations, I should say. So you just add them together, and that's more broadly speaking, this is called vector addition. And so if you have a vector is just a bunch of numbers. It's a 1D array. So if you have a vector holding the position for C, and then you've got the transform, which is 5, 4, then C plus T, you just add the components together. 4, 6, or whatever. Okay. Actually, that should be -2. Yeah. And so how you do vector, if you've got a vector that's x1, y1, and you're adding it to a vector that's x2, y2, then it just becomes x1 plus x2, commas in here, y1 plus y2. You just add the components together. Is the technical mathy explanation, but I don't like technical mathy explanations. I like simple explanations. Okay, so yeah, you just add the individual components together. So second thing is rotating. So in order to rotate something, you have to have 2 things. You have to have a point of rotation, and you have to have a angle of rotation. So here we have A, B, C, right? So A to B to C. Triangle is counterclockwise, right? And then we're going to rotate it this way 180 degrees, or pi radians if you're one of those people. Interestingly enough, Unreal Engine uses degrees instead of radians. It's probably easier to type 90 than it is to type pi over 2, right? So, yeah. Babylonian system for the win. All right, so if you look at it, A and D are the same thing, right? Because they're both at the origin. They don't change. But C is going to swing around and become F, and B swings around here and becomes E. So it's the same triangle, same shape, and everything. It is just rotated 180 degrees around the origin. So whatever, we typically use the origin as the point of rotation, but technically you can use anything. And so if this guy was at 2, 10 before, after rotating it 90 degrees, he's going to be at -10, 2. Do you guys see that? So if you do a 90-degree rotation, A goes from being 2 to the right, 10 up, to -10 to the left and 2 up. You rotate it again, and it's going to be at -2, -10. You rotate it again, and it turns into 10, -2. And again, it's really helpful to just eyeball it. you know, so you don't, you know, I'm just showing you conceptually before I show you the math on it. You guys kind of understand that conceptually? See how the numbers don't really change, they just kind of, the signs kind of flip. And that's for a 90-degree rotation, right? 180-degree rotation, 360-degree rotation. The numbers don't change. For other ones, they will change. Like if you were to rotate it like 10 degrees, then it'd be around here somewhere. Right? So what is the math? Any questions? No? And just, you know, if just, I always start by just like sketching it out on paper, because, you know, when you can physically look at something, like, I don't know, maybe it's just me, but like if somebody's like, well, here's the explanation, you know, clearly it's, you know, yeah, over x squared bar divided by the arc tan of y, you know, and there's a sigma in here. Like, clearly that's the explanation. My brain just goes, And then they're like, yeah, so what you do is you just add two numbers together. And you're like, okay. Yeah. I can add two numbers together. You know, when I was working for the UCSD bioengineering department, I sat in on a lecture just for me. The professor, who's one of the top professors in the field, was explaining how the heart simulation worked, which was really interesting. And it was all these like mathematical symbols, and some of them I knew and some of them I didn't know, and I just sat there kind of nodding like, oh, okay. And then he's like, all right, do you think you can implement that? You know, there's like, you know, this, and then there's like, I don't know, like a mushroom that if you eat it, it gives you magic powers, and then there's like, you know, hats and like things like that. And he's like, do you think you can implement it? And I was like, all right. So let me see if I got this straight. What you want me to do is take four numbers and average them. He's like, yeah. Sure, yeah, I can do that. Absolutely, I can average four numbers together. You know, like I sat there just like doing my best not to appear utterly dumb, and at the end of the day, it was like, okay, it's just averaging four numbers. Okay, yeah, I can do that. It's like on a 2D grid or something, like, and so basically every spot on the grid, you know, you're averaging the neighbors, right? That was it. I was like, okay, sure, yeah, I can do that. He's like, great. I was worried you wouldn't understand that. No, I got it. I always like seeing things visually before working on theory for it. Download Blender, mess around with the textures, vertices, yeah, or just Unreal Engine. Like if you just drag something around, you can see how it works. So before we get into the math on it, though, we need to understand the difference between local and world coordinates. Okay, so where are you going to? What's the point of rotation? Right? Is the point of rotation 0, 0 in the world? Remember, the world origin might be over here somewhere. There might be some mountains, you know, and like that over there might be the world's 0, 0. If you're rotating this triangle here around that, this thing's going to go flying. You know what I mean? That thing's going to go flying off into La La Land. And so usually when you rotate something, you rotate it around its local origin. And so when you're in Unreal Engine, and this is why I should not have quit out of it, when you're in Unreal Engine and you open up a mesh, you will see a giant white ball. It looks like, not like that. Giant white ball. And so the giant white ball, it's not drawing anymore. No, I'll just show you Unreal Engine. There will be a giant white ball, and that ball is the point of rotation. That is the origin, that is the 0, 0 for that local object. So the world has an origin, and the world's origin might be, I don't know where it is. Let's find out. So let's set this box's origin to 0, 0, 0. And then I will double click on it to zoom to it. So this is the world origin down here. Okay? So this is not very useful. And so if we were to rotate the box, around that origin, it would kind of go in an arc like this, right? It would kind of fly off into space because it's rotating around the world origin. We almost never do that. You almost never do rotations around the world origin. Instead, when you rotate it, you see how it's spinning around the box's origin, right? See that? The very center point of mass for the box. If we're to rotate this, the center point, you see how the center point's down here, right? See how the center point is down in the ground? Not center point of mass for this one. The place where it connects to the ground is the place where it rotates around. So you actually have to fix in your mesh where the origin is, because that is the place where it will rotate around. You guys see that? This is not rotating around the world origin, which is down there somewhere. Okay. And so if we were to come into this and open up the mesh, UV mapping, look, you understand what that means now. Vertices, pivot location. There it is. You see that right there? That is the local 0, 0, 0 right there. Okay, right there. You guys see that? And so you can adjust that, right? So you can move the 0, 0, 0 around, and that's the place that will rotate. Does that? That's where you're doing it. Does that make sense to you guys? Like every object needs, and so wherever you click on it, and the rotate wheel appears, that's the point that the box will rotate around. In that case, it's the center of mass. It's sometimes the center of mass. It's sometimes not. Like down here, it's like there. So if I were to rotate the staircase, I've now got modern art, right? So I've now made DNA. I need a second staircase for that, I think, but yeah. Does that, you guys kind of understand? So you need to have a local coordinate set for your meshes. Otherwise, it'll just, like if it was spinning around the world coordinate, it would be just flying around. Okay. I'm not going to quit this time just in case I need it again. So there is a point of rotation, and that's usually set by either, when you do it originally in Blender, you'll set like an origin point, pivot point, or in Unreal Engine you'll sometimes see it as a giant white ball. The white ball represents 0, 0, 0. Either way. Okay, and these things are also important. So local versus world coordinates is also important. Like, imagine you've got like an airplane, right? Maybe it's a rocket ship, I don't know. So if you've got an airplane, and you've got like, I don't know, like another airplane down here, and this airplane is going to shoot at this airplane, right? It's got what's called a look vector, or a forward vector, depending on which engine you're using, and that is the direction the plane is facing. So this guy not only has a point that is his 0, 0, 0, maybe that point is right there, he's also got what's called a forward vector, which is the direction that the plane is facing. And so if you shoot a bullet out of the plane, then the bullets will travel the velocity. Basically what you're going to write is the velocity, velocity, the velocity of the bullet is going to be equal to the forward vector of the plane, right? The direction the plane is looking is this way. And so you're going to grab the forward vector, which is usually a unit vector. In other words, let me write this again, it's a little more visible. The velocity of the bullet coming out is going to be equal to the plane's forward vector times speed. And so, let's say it's like 1,000 units per second or something. And so the forward vector is always going to be a unit vector. It's just the direction the plane's looking. So you multiply that by 1,000, and then you set the velocity of the bullet to that, and then the bullet will be traveling in the direction of the plane at a speed of 1,000. And the position of it, you set like a point on it. And so its position is going to be set to the plane's position, or the tip of the plane's position. So you set the position, you set the velocity, and then the bullet will appear here and travel in the right direction. And that's how you make games. That's why understanding the math is so important, and that's why it kind of bugs me that there's a lot of game development programs out there that don't teach the math, because they're not actually that it's not actually that complicated. It looks like it says hippos, tippos, the tip position. Yeah. So whatever. There's no eraser in PowerPoint. So the point is like, when you understand these things, then you can actually make games. Right? So you have a rocket ship taking off like this. You have a rocket ship, right? And so the rocket ship is going to have a forward, the direction that it's looking in. And that's interesting. And then you've also got the right vector, which is the direction to the right of it. And then you've got an up vector that's coming up out of the screen. And so every local coordinate system has an origin, and it has kind of its own X, Y, and Z, right? So every coordinate system has its own X, Y, and Z, representing forward, right, and up. And the world itself has, an X, a Y, and a Z, and these things are not the same thing usually. A rocket ship is, it may just happen to be aligned to an axis, but usually it's not. And so this guy might be traveling in like some diagonal, and so you can still say, okay, create a missile 10 units to my right. Okay, and then you shoot it in the forward direction. And so you usually use forward, right, and up when you're, making bullets, and dodge left. Okay, take my right vector, multiply it by -1, move myself that way, to dodge. You rarely use these in those circumstances. Okay. So there's the world coordinates, where you've got X and Y and Z, and the world origin, and then you've got the local coordinate system, which is based on the direction your object is looking. For example, if you have a demon, you've got a demon with some demon horns here, demon legs. Okay, and the demon is looking this way. Then you're going to write code, and we're going to learn that later. You're going to write code that says, can the demon see the rocket ship? Yeah, it probably can. But then there's a hero that's sneaking up on the demon here with a rock in his hand. And so you say, can the demon see the human? No. And so the human will be able to sneak up on the thing that looks like a bunny and hit it over the head with a rock. So basically, these are the fundamentals that will allow you make a happy little bird. Sure. There you go. There you go. And so the bird has a forward vector and an up vector and a left vector. And so every object in the world, when you care about the direction they're looking and positioned, then you use the local coordinates. Okay. And these are the basic building blocks of making a game. Can an AI see somebody? When you shoot a bullet, what direction does it come out? What velocity? If I hit accelerate and I'm driving a car, increase my velocity in the direction that I'm facing. Right. These are the most basic tools that you have in game development, and so it's really kind of important you understand them. Scaling is the third transform, and you don't have to understand this like mathematically, just conceptually right now. Okay. So your quiz is just going to be on transforms. So make sure you can do this. Scaling makes things bigger and smaller. like I said, scaling is kind of, you can do it. You know, I guess you eat a magic mushroom and you grow bigger, but like in Mario Brothers, it's not just scaling up Mario, right? It actually changes the art. So scaling's not as common as the other two. And so there's a lot of math that goes into these things. Translation, scaling, rotating, shearing, reflecting. We're going to learn the matrices like maybe next time. Yeah, let's just come in here. And you can see that you've got location, not lactation, location, rotation, and scale. And so you can just play with these values. Change it to 2. The thing scales up in all directions because I have the lock on right here. So if I unlock it, I can scale it more in one direction than another. Right? It usually looks pretty bad, right? But if you need to, it's there for you. It's really kind of gnarly looking. Scaling things usually doesn't look good. Like this, you see how the textures get really stretched out and stuff like that. So you can fix it maybe, you know, if you have a material, you can fix it by having different scaling parameters in the X and the Y directions. You know, this is scaled up, right? So, you know, this is not a good look. Even this is not a good look because these are supposed to be cobblestones and so they're like gargantuan. None of that looks very professional, you know. If you saw this in a video game, you'd be like, yeah, it's super, super lame. You know, this ramp here, you can see how it's all stretched out. It's not, the grass here is all stretched out. It's, yeah, in general, scaling is just not what you want to do. That's why Unreal uses these flat colors for the default stuff, like white, you know, and gray, because you can't see the fact, you know. See that it's all stretched. It's not a good look. So if you're gonna do that, then you need to make some smart materials that have different tiling factors. Okay. So here you see it's scaled 4, 12, 3. So it's scaled a lot more. This is what it would look like if it wasn't scaled, right? That. And you see the texture looks a lot better on it now. And also, I'd probably take issue with the different color scheme we have here, but we started this semester by just going garish, so, you know, whatever. It's a deliberate decision. It got better, though. There. Yeah, so location, rotation, and scale. Translation, rotation, and scale. If I translate this is using world coordinates, right? So these numbers here are world coordinates. But then the rotation is using local coordinates. And then scaling also uses local coordinates. So scaling doesn't scale from the world, it scales from the origin, right? So you see how it goes from the origin of the box when you scale in one direction. So what rotation and scaling use the origin of the object to scale from. And location uses world coordinates. It's funny, it's reflecting the it's actually reflecting the graphic for the for the rotator. Okay, so that's it for today, guys. I'm gonna just throw up a little quiz on translation. So you're gonna have to do math, adding 2 numbers together, and then we will come back next time and try and get your landscape and river things cleaned up and fixed. If you don't have a grade on Canvas now, then that means there's something you need to fix on it if you want to get the full 100%. I want my students to get 100%. I don't see grades as punitive. I see grades as just like, you know, an encouragement to do work. Because if there's no grades, students don't do it. You know what I mean? So hopefully you guys are encouraged to do the remaining parts. How do we set tiling for flowers in the automatic roads? There is a density thing. So in the grass, meadowgrass. So I created 5 different types of flowers, and The density chooses how often they appear, and then you can choose the culling distance. That's the max distance they draw it. Scaling, you can change it so that it scales taller and fatter and thinner and stuff like that. In general, though, it's not gonna change. These are not gonna change, but you can make it, get bigger and smaller and stuff like that. Randomly rotated, aligned to the surface. So yeah, and then you create one of these. You click on the plus here, and you create one of these. This is inside the grass, the landscape grass thing that I created. And then you click plus 5 times, in my case, and then I just picked a different flower for each one of the different flowers. And then by setting the density, that chooses how thick that flower grows. So 400 is the default, and it's really thick. So I changed these down to 200, this down to 100, this to 200, this to 200. And so by adjusting the densities on these things, you can... is there a place to get free flowers? Yeah. Good question. The starter pack doesn't really have any good options for foliage. It's called Flowers and Plants Nature Pack, and it's free. So you just go on the marketplace, buy that, quote unquote, buy that for free, and then it comes with lots of flowers. Lots and lots and lots and lots and lots of flowers. So it is pretty cool. Pretty cool. Yeah, and then so in your landscape, Smartland, what you do is you just create a landscape sample. So this is called a landscape layer sample. And then the only trick here is that you type in the layer exactly, the name exactly. So WAB, not layer WAB. That was a mistake I made. And caps matter as well. So the parameter name is going to be WAB. And then you feed that into a grass node, landscape grass. And then you choose a landscape grass object. I've got meadow grass and I've got road grass. Is road grass? Which one is this? This one's road grass. So I'm going to use meadow grass. Save. Compilation errors. Yeah, you. Material can only contain one grass node. No! Alright, then I've got to add another one here. That's the right way of doing it. And so meadow grass. There we go. Okay, so this will have the road texture create my road grass, and my WAB texture will be covered in meadow grass. So if I save that, come back in here, then did I not type it right? Well, that's the process you go through. I don't know why it's not appearing. Let's see. Nodes, landscape, paint. I probably typed in something wrong, but that's the general idea. So it's going to carpet whatever layer you put in there in that. See, was it dirt? Which one was the one that has the grass on it? No, that doesn't matter. That's the general idea. So, layer road about the redo and the presentations. Yeah. So yeah, do your textures on by Thursday, and then the redo on the games, the board games. Do those by Thursday as well. And so we'll have a little presentation day on Thursday, and then and then we will. Let's not save this. I don't know what I did wrong. Maybe it was a different material. Let's see here. Went underground and looked up to see if they're spawning. Yeah. Road grass, and this will be road. And so if I landscape layer sample and call him rock, none rock, thank you, rock, and feed you into here. Oh, you know, it might have been that thing where like you have to reapply the material to the landscape. Yeah, let me see. Okay, so let's do the thing where we change that. Yep. No. Maybe. Yep. Yeah. So it was working. You just have to. Remove the material and reapply the material. I don't know why it doesn't update properly. It seems like a bug to me. So you can see the rock now has just a huge amount of flowers growing on it, and so the that's only the place where I've spray painted rock specifically. So that's not the output of the Worldline blend. But anywhere where I've spray painted meadow, spray painted rock, then they will get those different grass layers applied to them automatically. That looks pretty cool. That looks pretty nice. See different flowers. These. And there. Okay. So that's it for today. So yeah, if you want to get that to work, then I don't know why it does that. I wonder if it's something I'm doing wrong or something, but yeah, just if your landscape isn't updating, then drag a different material onto it, then drag the material back onto it, and it'll appear. I don't know why it does that. Apply should be doing that. Yeah. I'll look into that more, see if that's something I'm doing wrong or if that's something Unreal is doing wrong. All right, thanks, you guys. Thanks for coming out. Good work on your stuff so far. Get her done, and we'll have a nice presentation day in a couple days. And I'll put up a little math quiz for you guys, just adding numbers. Shouldn't be too bad. All right, see you guys.